All right, so today we're going to be covering 4.7, which is explaining the forwarding per hop behavior for QoS, such as classification, marking, queuing, congestion, policing, and shaping. All right, so what is it? Forwarding per hop behavior, or PHB, is a key component of quality of service, or QoS, in networking. So, focusing on how packets are handled at each hop or node in the network. Now, we're going to break down the key aspects involved in PHB for QoS. So, let's get into it. So basically, what's going to be covered in this video is classification, queuing, congestion avoidance, marking, congestion management, policing, shaping, and that's it. So let's do this. So let's start off with classification. Classification is the process of identifying and categorizing packets based on predefined criteria. This can include examining headers for specific fields like the ones below. So like the protocol type would be used for things like TCP, UDP, ICMP, and stuff like that. Port numbers would be used to prioritize certain applications like VoIP or voice over IP or HTTP traffic. DSCP values would be used in differentiated services to mark packets for QoS handling. So it's just things like that, right? Where it's just classifying what does what, right, on predefined criteria. And then along with that is source and destination IP, which would be for it to like prioritize traffic from or to specific locations. Marking involves tagging packets with specific values that indicate their QoS treatment. So this is often done using IP precedence, which is an older method using the first 3 bits of the IP header or type of service field, or DSCP, which is a newer, more flexible method that uses 6 bits of the TOS field, allowing for 64 different values. Marking helps networks recognize and prioritize the packets according to their requirements for QoS. So that's what marking is. Queuing is when basically mechanisms determine how packets are buffered and scheduled for transmission. So common strategies of these are FIFO, or first in, first out. It's simple, but it doesn't provide QoS differentiation. There's also priority queuing, which is when high priority packets are sent first. So you're going to see this on the CCNA. I saw this. So it's PQ. And then weighted fair queuing, which is WFQ, where packets are assigned weights and resources which are allocated proportionally. And then there's class-based weighted fair queuing, which is CBWFQ. And it's similar to WFQ, but it allows for specific class-based configurations. So yeah, basically weighted fair queuing would be like voice over IP is really important, so we're going to send more traffic there so that the call is smooth compared to someone who's sending like an email. And that's exactly the same thing here. It's just class-based configurations. Congestion management. It involves techniques on how to handle packet overflow in queues. So there's things like random early detection, or RED, which proactively drops packets when queues start to fill so that it can avoid like congestion collapse where it gets too full. Then there's also weighted random early detection, which is WRED. It's similar, but it just provides differentiated dropping policies for different traffic classes. And then there's congestion avoidance. And what it does is it aims to prevent congestion before it occurs. So basically it's like, think of it as I forgot. But yes. So basically it avoids congestion before it occurs. And it involves traffic shaping, which controls the rate of traffic flow to smooth bursts and ensure consistent traffic rates. So the techniques include token bucket, which allows bursty traffic, but it limits the average rate. And then there's leaky bucket, which smooths the traffic rate to a steady rate. And traffic policing basically enforces rate limits and can drop or mark packets that exceed the defined rate. So yeah, that's it. It's just like a pre-measure, basically. Like, and it's going to make sure that congestion doesn't happen before it happens, instead of fixing it when it happens. And there was something related to it, but I kind of forgot. All right, and then there's policing. So what policing does, it monitors the traffic rate against a predefined policy and takes action when the rate exceeds specified limits. Some actions are dropping those excess packets to enforce the strict rate limits, or marking them down to lower their priority, and then that allows them to be dropped first in case of congestion. So if it's like less important, then those will get dropped first in the case of congestion compared to something that would be very important, like a voice over IP call. Simple concept. And that's basically it for that. There's also shaping. Shaping is similar to policing, but instead of dropping the packets, it buffers them to smooth out bursts and ensure that traffic adheres to a specified rate. So this is where it was like smoothing it out, right? The leaky bucket and whatnot. And it's token bucket shaping, which allows traffic to burst up to a certain limit, but ensures long-term average rate conforms to the policy. And then there's also hierarchical shaping, which applies shaping policies at multiple levels of the network hierarchy. So, yeah, there's a network hierarchy, and it applies its policies at multiple levels of it. That's it. That's all for this video. I hope you're liking this series. I came up with a new strategy. Tell me in the comments if you guys like it, but it's like short and sweet. I tell you the parts that I would think is needed. There's no rambling, nothing. I'm not monetizing these videos, so I don't care about the 10 minutes or whatever. But if you guys like this, then like, comment, subscribe, and let me know in the comments. But if you guys want me to go back to the old where I was running on for like 18, 20 minutes going into super detail, let me know, and I will change that. So it's all for you guys. So if you guys preferred my previous style, then let me know. But I think this style is going great. I really like it. Anyways, thanks for watching, guys. Hit that subscribe button and see you soon. Goodbye.